Good afternoon, everybody. Welcome to class today. Thank you for joining me, whether you're watching live or you're watching the recording. I appreciate you watching and I appreciate you getting involved. So this week, or really end of last week, depending on how you look at it, right? Time is just a frame of reference after all. We're looking at Module 1. Module 1 officially opened last Friday. It'll be ending this Thursday. And we're still in what I might call like the simple phase of the course, right? Like with this course, we sort of build up. And so we will start kind of small and ramp up over time. So that's kind of our goal. So we're still, in the very early phases of what we're going to be doing in this course. So still relatively simple, still just sort of getting acquainted with our programming environment and learning how to write code and sort of learning what this is all about. So today, what I want to do is I want to just kind of give us a little bit of context for what we're doing, define a few terms, give a little bit of context, and we'll do a really quick demonstration as a part of it. So that's our plan for today. Probably won't take very long. I think we're looking at around 30 to 45 minutes today. Remember that if you're watching with me live, you have your option to send in your questions. You can send it in via email, via the live chat here in the live stream on YouTube, or via Microsoft Teams, however you choose to do so. And if you're watching the recording, please, send your questions in as you're watching via Teams or email, and I will answer them as quickly as possible. And so we're introducing Python and talking about getting started with programming in Python as a part of this course. And so I think one of the first things that we need to do is sort of define what a program is. What does it mean for something to be a program? And when we're talking about a program, really what we're talking about is a sequence of instructions that specify how to perform a computation. So when we say sequence of instructions here, we'll define an instruction here in a minute. But you can kind of think about an instruction just like you'd think about an instruction in any other walk of life, right? Like if you get if you go to Walmart and you buy one of those pieces of furniture that you have to put together, that you can get from either like Walmart or IKEA or whatever. You open up the box, you pour everything out on the floor, and you usually have some sort of instruction sheet. And that instruction sheet gives you a step-by-step list of things that you need to do in order to build that furniture. And that's one of the things that we kind of talk about a lot for programming too, right? Like we have this picture on the box, which is the finished piece of furniture, or I'll also talk about it in terms of a puzzle. We got this picture on the box that is the finished item. And we've got all these different pieces and all these different parts and all these different ways that we can put them all together. And so, putting them together in a few different ways could result in the same picture, result in the same piece of furniture, right? So that's what we end up with here, right? But the key term out of this first line here is basically computation. And typically when we think about computation, we think about math, right? We think about like, I'm going to do I'm going to do these computations. I'm going to do these complex systems of equations. And I'm going to derive some mathematical answer. And that could be what we're talking about, right? A computation very well could be mathematically related. But we also have things called symbolic computations. And a symbolic computation could be a search, or playing a video, or playing audio, or, opening up a document or editing a document. And all of these things are computations. And, one of the ways that we can look at it is basically through the lens of, kind of what we talked about last time in live class, at least for a second, is this idea that programming itself is specific and that we're writing in a language that's basically breaking things down to be in a language that our computer speaks. And our computer speaks binary. Our computer speaks a series of zeros and ones. When we think about things in that sort of way, like, we use the terms zeros and ones. But what we're really talking about there are like ons and offs. If the switch is on or if it's off, that's going to give us our 0 or our 1 for a binary. But everything sort of breaks down into that binary, into those sequences of ones and zeros. And so really everything, whether it is a complex math equation or playing a video or whatever, it's going to break down into that binary at its core. Right? And so when we break that down into binary at its core, then there is math going on there, right? We're converting this action or this thing into this binary. And so there are computations going on there. We said we'd talk about what an instruction is. And for our purposes, really, an instruction is just a line of code, right? So we can think about that instruction sheet from our piece of furniture or whatever. Right, we have these step-by-step instructions that tell us how to start with these pieces of wood and end up with this piece of furniture. And so a single instruction from our instruction sheet is just one directive telling us to do a specific thing. And when we're working with programming, when we're writing code, that's all we're really doing with an instruction, right? That's telling we're giving our computer the instruction to do one specific thing. So it's a line of code. And the details for our instructions can look very different in different languages, right? The way a program is written, that's called syntax. Syntax is basically the rules for a particular language. So if you think about English, the English language has syntax. And, when we're writing sentences, we're dealing with syntax. We have to know, like, okay, so some sort of punctuation goes at the end of the sentence. Sentence starts with an uppercase letter, so on and so forth, right? There are these rules there. And there are rules in different programming languages in terms of how you can write things versus how you shouldn't write things or how you can't write things. There are rules there. However, there are a few basic instructions that appear in just about every programming language, even though they look different. They're there. And those are input, output, math, conditional execution, and repetition. And we actually put these into a bit of a different order as well. Depending on how you talk about them, these could also be termed as our REPL. REPL. And so REPL is an acronym that stands for read, evaluate, print, and loop. And we can take these 4 things and we can map them out into these 5 things that we have here. It just depends on kind of who you're talking to as to whether they would call them like a REPL or input, output, math, conditional execution, repetition. Because really input is our R in REPL. R in REPL stands for read. Input is our read, right? So we're just getting data from somewhere, whether it is keyboard, whether it's a file, whether it's a network, some other device, whatever. We're reading data from some input. So our input is our REPL. E here stands for evaluate. And in this instance here, we have 2 items that are evaluative items. That's the ability to do math and the ability to do conditional execution. Right, so if my computer needs to check something or do something in order to perform a calculation or solve a problem or check a condition, basically evaluate some sort of item or evaluate some sort of operator, that's going to relate here to our E. That's the evaluation phase. And that's for both math and conditional execution here. Our P in our REPL, that stands for print. And so if we look at, there's my pen here, there's my pen. If we look at our print here is basically our output. So being able to display the data on the screen, save it to a file, send it over a network, right? That's the equivalent to our print here. And then finally, our repetition. Our repetition is our loop, right? It's just the ability to do something over and over and over and over and over again, right? So that's what that is. So whether you hear it being spoken of in terms of the REPL, in terms of the read, evaluate, print, and loop, or you hear it broken down the way I like to do across these 5 different items of input, output, math, conditional execution, and repetition, just know that it's the same basic thing and the same base standard instructions that you see in basically every programming language. The way that you write these instructions is going to vary. Again, that's syntax, but these same instructions are going to prevail in different programming languages. So from here, we can talk about what is Python. Python is a programming language created by Dutch programmer Guido van Rossum. Python is a high-level programming language, and one of the things that we talk about when it comes to high-level and low-level programming languages are basically how close they are to English versus how close they are to machine code. So if it's closer to English or a language which humans speak, it is considered to be a high-level language. If it is closer to machine code, it is considered to be a low-level language. So some high-level languages would be things like Python, Java, C++, C#, Rust, Go, all sorts of high-level languages, right? These are our most common languages. Our low-level languages would be something like assembly, right? Something that is pretty close to being machine code. Like if we looked at an assembly programming language example, we would see if we look at this, there are some things that we can understand here in English, right? Because there are English words, but if we look at them here, these are actually comments. And so the actual code here is what we have down in this area, and the vast majority of that means nothing to me. C01, E8D, F0, in hex, right? Like it's a bit difficult for us to understand. But then if we look at Python, we see words like if, else, for, range, right? We see things that we understand. And so, it's not going to be fully one way or another, right? It's not going to be fully English or fully computer language, but it's going to be the proximity of that language to one side or the other. That's going to determine whether a language is high level or low level. Now, Python is open source and community driven. You can actually go on to GitHub and see the Python source code, which is what I've done here. Right? I've just went ahead and pulled it up. So this is the Python source code. You can see that there are, if I go into here, we can actually see requests and changes that people have made. So if I click C Python here, this is the actual Python source code. We can see once we get into here, we have pull requests. These are changes that regular people have made, that they have sent a pull request back to the owner of the Python repository or the owners of the Python repository. That will potentially fix a bug or add a feature. If we look here in the Issues tab, these are all identified issues that have been assigned, or their feature requests that have been assigned and or will be assigned in the near future for people to start working on them. So who are these people? These people are really anybody, right? And so that's the thing about GitHub, is that anybody can work on these projects on GitHub. I can take and I can make a copy of the Python code base to where that I could have my own copy of the Python code base. In turn, I could look for these issues here. I could ask for these issues to be assigned to me. I could work on them. I could send a pull request back. Then that code could be reviewed to ensure that it's not malicious and actually does solve the problem, and then implemented if it works, right? And so one of the interesting things that I like to show people here is that when we look at the code base for Python, one of the interesting things is people, oftentimes people don't realize that, like, a newer, higher level programming language is probably more dependent on an older programming language. Like, we look in here and we see a lot of these .c files, and these are C programming files. Right? So Python is built on the programming language C. And so if I look at something in here, I can see some C programming language that is kind of converted and looking for things that are written in Python. So Python gets converted to C, sort of, if you want to think about it that way, which then gets converted to machine code by the interpreter, which allows our computer to run a set of instructions. And so that is sort of important to kind of realize when it comes to some of the other things that Python does in the future and how the actual Python code base works, is this understanding that, it's not just its own language sort of out in the wilderness, that it is built on another programming language that already exists, specifically C. Right? And so that's just sort of interesting. Like, that's, something that you're not going to be required to know or do in this course, but it does kind of help you build a foundation here. We say that Python is a batteries included programming language, which means that just a standard Python distribution includes a lot of what we call modules. And you might hear some people call modules libraries. Sometimes I'll use these terms sort of interchangeably. And what that essentially means is, you can kind of think about a library in Python in the same way that you'd think about a regular library. Right? When it comes to the knowledge that's in certain books, I don't need that knowledge all the time. Right? Maybe sometimes I just need it for certain times, and then I can move on to something else and I'm good, right? Like, I just need to look up something, then I can know it for a little bit, and I don't need to carry that book around with me all the time. Right? And so that's what we're talking about here, really, when we're talking about modules or libraries, are these items that you can sort of check out. Right? So they're included in the Python code base, but they're not always in there by default because you don't always need them. Sometimes you need them, sometimes you don't. So if I need them, I can import them. If I don't need them, I don't have to import them. And that will, keep the size of my program small. And so we'll look at a few different modules throughout the course as we're doing different things. But they're just items that we can import and we can do things with. Sort of use that knowledge temporarily, and if we don't need it in another program, we don't import it, and then it doesn't add that bulk to my file. Another thing is that Python is dynamically typed. Whereas, if you look at a programming language like Java, when I'm writing Java and I want to make a variable that contains an integer, or I want to make a method that returns an integer, I need to make a promise to my compiler that that's what I'm going to do. I need to make a variable that is int whatever, or a method that is int, public static int whatever. But in Python, Python handles all of that on its own, right? Python's able to look at the data, determine what kind of data is there, and work with it accordingly. And so that's what it means for something to be dynamically typed. I don't have to make a promise to the interpreter that I'm going to use a string or an integer or a floating point number. I just use it. And then in the output, I get my results, right? It just kind of looks at it, it understands it, it gives me my results. And so that's sort of Python in a nutshell. Why are we using Python? It's one of the most widely used programming languages in the world. When we were kind of redeveloping the programming and web development program here, one of the things that we did was we kind of sat down and we looked at surveys of the most widely used programming languages. And we found year after year after year after year, the same three would always rise to the top. And those three were Python, Java, and JavaScript. And you'd have several others that were kind of competing right outside of the top three. C#. Sometimes Swift would break into the top 10. C++. Go, Rust. There's several different ones. But time after time after time, in some order, the top three were Python, Java, and JavaScript. So they get used a lot. And so there are jobs out there and there are opportunities to use this language in the working world. And really, Python is one of the more versatile languages. I can use Python, although it's not often used for software development and game development. I very well can use Python for software development and game development. We see Python used a lot more for data analysis, for data processing, for scripting, that sort of thing, right? So you can really go into any direction that you want to go into with programming with Python, because it is one of the most widely used and it's one of the most versatile. It's also a tried and true language. People like to think of Python as a younger language because it only really gained popularity within the last, 8 to 10 years or so. But it's been around since 1991. So Python's actually been around since before Java. Believe it or not, Java would come around a couple years, a year or two later. So Python as a programming language has actually been around before Java. It's a tried and true language. It's something that's been tested and used and developed for, 33 years now. Right, so we know that it works and we know that it's good. It's easy to get started with, right? The language is very friendly. There's not a whole lot of syntax to remember. Really, the biggest and kind of toughest thing to remember in Python are the indentation rules, which it'll be a couple weeks before we get to those, right? But that's sort of the thing that people struggle with the most when it comes to Python syntax is indenting. But in general, Python syntax is really easy, so it allows you to kind of focus on learning programming logic, learning those, learning that REPL or that input-output math conditions, loops, or repetition, without having to, struggle writing syntax. And it is called Python because of Monty Python's Flying Circus, right? Guido van Rossum really liked that show, and so he named his programming language after it. When we run Python, there are different reasons or different ways that we can run Python. For simplicity's sake, we'll be using an online IDE. IDE stands for Integrated Development Environment, and that integrated development environment that we'll be using is Replit. Replit.com, repl.it. You should have your account, be able to do it. You can use the standard Python IDE, which is called Python Idle. You get that when you install Python. For our purposes especially, I don't necessarily recommend it for this course. I think it's a lot easier to use the online IDE. It allows you to test faster. It's easier to turn things in. It's easier for me to grade. So, that's a thing, right? So as we're approaching this, one of the first things that we would want to do is we'd want to visit Replit here, which is here somewhere. I've got too many windows open. Where's my Replit window? Where is it? close it accidentally. Let's open it back up. Let's open a Replit window. So in Replit, after you log in, you see something that looks like this. We kind of went over this last week in the orientation. We can create a REPL in 3 different ways: here, here, or here. Create a REPL. We're using just plain old Python. You probably wouldn't have the favorite there yet, so you're going to search Python. And remember that it is just plain old Python. And we're going to create REPL. Now, the first thing I want to see, and I'm going to want to see this in every single program that you write going forward, is the shebang. The shebang statement. So every Python program that you write in this course that you turn in should have a shebang at the top of it. And this is not something that makes your program run or not. This is one of those best practices that's good to have, that we really should be doing. Because it's basically a script that we can put into our code that allows our code to be executed like a standalone executable. So if I have Python 3 installed on my machine, if I have a shebang statement at the top of my Python program, then it will automatically run it and do its thing if I double click it. Right, so that's pretty cool to use there. And so my shebang statement is just hash bang. In programming, we oftentimes call the exclamation point a bang. Got the hashtag symbol there as well, so hash bang, that's where we get that term. Shebang becomes a portmanteau of hash and bang. So from that we add /usr, /bin, /env, space Python 3. And just like that, we've added our shebang statement. Now, the next thing I want us to do is I want us to write a hello world. Because really a hello world is one of the first things that you do in programming typically, and it's basically just, announcing yourself to the world that you're, writing code in this particular language. In a lot of programming classes, you'll see that the hello world is like one of the first assignments that you get. But in Python, the hello world is really, it's too easy. Right? So I don't make you do a hello world in Python in this class, although we do something a little bit similar, although it's a little more of a thinker. It's a little more logic heavy when it comes to trying to come up with the equations that you have for the first module. But basically all I want to do is I want to start out with a print statement. And our print statement here is a function, and we know it's a function because it has parentheses immediately after the word print. In a programming language, if you see any sort of word with a pair of parentheses immediately after that word, that typically means it is a function or is related to a function somewhere. And so this is the print function that we have here. And the print function works with something that we call the print stream, and it allows you to print out data to the console, and the console being, the part here on the right-hand side. And so in between here, I would put my string of hello world. Right? And what makes it a string? The fact that it is in between quotes makes it a string. And when we're thinking about a string, right, we think about that really specifically because a string is basically like if you've ever been to a birthday party and you've seen one of those banners that somebody might have where they have like a string or maybe a piece of cardboard, and there are just individual letters sort of hanging off of it. Like so. Right, that's kind of where we get this idea of a string from. One of the big key things for us to remember is that words mean absolutely nothing to our computer. Our computer is a pattern recognizer. So if I have a string like hello world or happy birthday or whatever, the words happy and birthday or hello and world mean absolutely nothing to my computer. What means something are each of these individual letters. And so we take each of these individual letters and we put them together into one string of characters, and that's a string. And that's basically just creating a pattern of zeros and ones that represent all these characters, kind of like what we looked at last week when we were looking at ASCII values and things like that. And so we get each of these items on the line. And it's actually interesting because we can actually go so far as to address a single one of these characters, which is pretty cool. But if we hit the run button here now, right, we'll get hello world to the console, right? It'll print, it'll go into memory, find that print stream, send that out through the print stream and give it to us in the console. But the fact that, all of these letters are just individual characters that are just kind of hanging on a line, individual characters that are just kind of grouped together, is evident if we add some square braces here and we put a number inside of these square braces. And we'll talk more about what this is and how it works. But if I did that, right, and I put like square braces here and put like a 7 in it and hit run, we get O. And that specifically is this O right here, right? It's just in that 7th position on the string is this O. That is the character in the 7th position on this string. So if I were to put a 6 here, that's going to give me the character in the 6th position, which is going to be that uppercase W. Right, so this is just a quick demonstration. We'll talk more about what's going on here and why this works a little bit later on in the course. But this is just to demonstrate to you quickly what I'm talking about when I say, words don't really mean anything. It's just characters in a group together. I can address every single character that's in that string and get it individually, so they're just kind of in a group there. But that's my hello world, right? Like, that's pretty simple. I just put print, put my parentheses, put my quotes, put whatever I want to print out to my console in those quotes, and it prints it. So it's pretty cool, right? Like, it's just that basic. And as we go on from here, it just kind of stays pretty basic. Moving on from there, we do have arithmetic operations, right? Our basic arithmetic operations are plus, minus, multiply, and divide. And of course, we can do multiple at once. Right, so I can do, say, print 5 plus 2, print 7 minus 3, print 5 times 7, print 20 divided by 4. Right, and so we can see here as we look at this, right, one of the things that we notice is that while words and characters mean nothing to my computer, numbers do, right? My computer loves doing math. I often say that one of the reasons that math was invented one of the reasons that computers and programming were invented in the first place is because math is hard. Right? So if we look at this from this perspective, what we can see here is like, well, words don't mean anything to my computer. Letters don't mean anything to my computer, but numbers do. So we can see that numbers are not in quotes because we can do math with them. We can't do math with strings, but we can do math with integers or numbers. And here we're representing an operator for each of these basic operations. And so if we printed this, what we would expect to happen is our program's going to run from top to bottom, right? So it's going to print hello world, it's going to print 7, it's going to print 4, it's going to print 35, it's going to print 5. Right? So that's what we expect to see there. And that's exactly what we get. Although there is one interesting little instance here, and that's the result of that division problem there. We got 5.0 instead of just 5 flat. And that does go back to that idea that Python is built on top of C. Python might be dynamically typed. C is not. So in order to do a division problem and to maintain the amount of precision necessary to get a good answer in a division problem, you need to make sure all your numbers are floating point numbers, and so it gets returned back as a floating point number. In this case, 5.0. Now, as I mentioned, we can use multiple of these together. It follows the PEMDAS rules, parentheses, exponents, multiplication, division, addition, subtraction. Right? So if you want to make sure that one thing happens before another thing, you can just wrap it in quotes. Right? And so you can see here, I have one set of quote, or wrap it in parentheses, rather, I should say. And you should see here that I have this one set of parentheses for this print statement, and another set of parentheses to start doing my math with. So if I want to make sure that 5 plus 8 gets done before I divide it by 4.25, then I want to make sure that I put that in its own set of parentheses. Because otherwise it's just going to follow PEMDAS, it's going to follow the order of operations. So we can actually put that in here again and say without those parentheses, which would just be 5 plus 8 divided by 4.25. In this case, it's going to prioritize that division problem over the addition problem. So instead of dividing 13 by 4.25, it's going to add 8 divided by 4.25 to 5. And we'll see there that that is two completely different answers. 3.05 and a bunch of numbers, 6.88 and a bunch of numbers. Two different numbers, two different results. Could be very drastic if you didn't have that precision or didn't set up your equation right. There are some other arithmetic operators that are pretty interesting. For example, we have our asterisk. So one asterisk, as we see here, is multiplication. Two asterisks is exponentation, or exponents. Right, so if I did something along the lines of print 10 to the 5th, right, that's going to give me 10 times 10 times 10 times 10 times 10. Right there it is, 100,000. Another item that we have here looks like a percent symbol. We call it a modulo. A modulo gives you the remainder of a division problem. So if I said something like 4 divided by 2, 4 divided by 2 is 2. But it's 2 with no remainder, right? 2 goes into 4 2 times evenly. So if I said 4 modulo 2, my answer is 0. If I said 5 divided by 2, my answer would be something like, what is that? Like 2.5. Right? Of course it is. But we have this remainder here. We have this item that's not a whole number. So if I said 5 modulo 2, my result is going to be 1, right? Because there's 1 left over after dividing 2 into 5. It's the remainder. And so this is a great operator to use to sort of determine, like, if something's even or odd. Because I know if I have a value and I say print 13 modulo 2, well, if the number was even, I would expect it to have 0 remainder, right? So I would get 0 as the result of this. But if it was anything greater than 0, then I know 2 doesn't go into it evenly, which makes it an odd number. And so I run that, and we see there that I end up with a modulo of 1 for 13 modulo 2. Or technically a modulus of 1, the result of a modulo problem is a modulus. But these are our basic operators here. And so I think we're more or less ready to sort of wrap up for today. I said 30 to 45 minutes today. We're at about the 40-minute mark. So I think once I'm done talking about debugging here, that'll put us almost exactly at the 45-minute mark. I have just a little bit to say about debugging as we approach all modules. And for this module, the biggest thing for us to realize is just that programmers make mistakes, right? So, the original programming bug was called a bug because it was an actual bug. It was a moth that flew into a mechanical computer that shut things down. And it's just sort of been kept that way going forward. But, programming in general brings out a lot of strong emotions, right? Just in general, we all want to be really good at things right out of the jump. And with programming, that's not always possible, right? It's a whole new language that you're trying to learn that you've never really spoken before or done anything with before. So it's important to realize that you're not going to necessarily know how to do everything out of the gate. It's fine. Struggling is fine. In fact, it's necessary for growth. Right? Like if you just were given the answer every time, you were trying to figure out the solution to a problem, you're not going to learn anything. You're not going to grow from that. So struggling from the perspective of programming is actually beneficial to you. Now, I don't want you to sit there forever and just bang your head against the wall when you absolutely have no clue. But struggling a little bit is to your benefit because it's going to help you grow. So learning how to debug is incredibly important, but it's just as important as just being persistent. Now, one of the assignments that you do asks you to kind of make mistakes in your code and just see what happens as a result. And so next week in our live, one of the things that we'll talk about is more about how to interpret these results and what they all mean. So I think that's where we'll wrap up for today. If anybody's got any questions, feel free to send them in while I'm wrapping up. If you're watching the recording, remember that you can send me an email or a Teams message with your questions. But we'll hang out a minute or two here after I stop recording here, just to take questions if anybody is here with me who has them. But that is all that I have for you for today. Thank you for watching. We'll see you next time.